So I'm Siddharth Yadavan. My roll number is 223662644. Today I will walk you through my Bayesian network analysis of New Zealand maritime accident from January 2022 to December 2024. In my 4-page report, you will find the data sources, screening setup, variable definition, discretization, exploratory analysis with key visualization, and yeah, just 1 second. Bayesian network structures and parameter learning, 4 inferior queries and their interpretations, discussion of limitations and future work, references and code, and the appendix how to run all of the things. So here's my code. So in my code I have used almost 5,985 accident records from Maritime New Zealand filtered to date when I had weather from January 5, 2022 till December 31st, 2024. Weather came from a local, um, yep, just 1 second. Weather came from a local.csv whose timestamp I passed via lubricate TMY, then averaged by month to ensure every action matched a month weather. I ended up with 16 variables, the 8 mandate factors, what happened, where happened, sectors, numbers of injured, vessel class, gross tonnage, safety system length overall, 4 weather measurement, temperature, humidity, wind speed, and precipitation, and the temporal features, year, month, and day of week. So continuous fields were forced to numeric, and inputs with medians and all were discretized into low, medium, high tiles. For structure learning, I used 4 state-of-art algorithms: MMHSSC, hill climbing, PC stable, Tableau search, which is a global search BIC. Parameter learning was done via maximum likelihood estimation with bn.fit function. Inference used grain query grain for conditional probability and bn-learn dsep and bn-learn mb for d-separation and Markov blanket. So the key findings that I had were the key findings. This is the exploratory data analysis, and the key findings that I had was P cap size in harbor was almost 0.37. Cap size remains a significant harbor risk. What happened is not independent of gross tonnage. Deseparation is can be false, and Markov blanket of safety system can be equal to what happened in sectors WS bin. For the probability of grounding with high winds is equal, it might be 4.45, which means commercial vessels are vulnerable in high winds. The limitations were monthly weather smoothing may hide daily spikes, other unobserved factors. Vessel age, operator training, current harbor. Future work could incorporate high resolution weather and additional vessel metadata. Beyond maritime safety, Bayesian network excel at any domain with complex probability dependencies, for example, healthcare risk prediction, modeling comorbidities and treatment outcomes to personalize patient care, supply chain resilience, predicting disruptions across interdependent suppliers and logistic variables. Building this project taught me the importance of thoughtful data, pre-processing, aligning dates, handling missing values, discretizing appropriately, how different BN structure algorithms can yield varying network complexities, and the need to compare them rigorously. That Bayesian networks are powerful for transparent, interpretable probabilistic modeling, but depends heavily on high quality data. Overall, I feel much more confident in applying BN methods to real world data, and this is the final result that I am getting by merging and cleaning and by taking all the data sets rows together. Thank you for watching. The full report with figures, tables and code is submitted alongside this video. I am happy to take any questions.